Hi, I'm Lynn Hedrick. I'm the chair of the Irvine Page Award Committee, and I'm here with this year's first finalist, Andrew Murphy. So I wanted Andrew to introduce himself and give a little bit of background about where he's from and how we got started in science.
Thanks, Lynn. Yeah, so I'm Dr. Andrew Murphy. I run a lab at the Baker IDI in Melbourne, Australia. So I did my postdoc with Alan Tall and have recently, at Columbia University, and have recently moved back there to sort of start my own laboratory. So, you know, I've had like a long-standing interest in cardiovascular disease, and now it's sort of my time to branch out and do something a little bit different than I was doing with Alan, but really continuing a lot of those same themes, which was discovering how my monocytes are produced in vascular disease.
Right, and so the topic of your award presentation today is?
Yeah, so I'm looking at how rheumatoid arthritis is associated with an increased risk in cardiovascular disease. So it's sort of a really important area, because what most people don't know is that people with rheumatoid arthritis actually mostly die of cardiovascular disease, and they have a threefold increased risk. So I think it's an understudied area, and it's something important to tackle.
So that association with rheumatoid arthritis and cardiovascular disease is something that people really don't realize.
No, they don't. And what's interesting is, you know, these people come in and see a rheumatologist because they've got inflamed joints, and when they get their routine screening, they don't present with any cardiovascular risk factors. They largely have normal LDL cholesterol. They're not obese. They may have a little bit of hypertension, but it's not that prevalent. So, you know, most people associate rheumatoid arthritis just with inflamed joints, but there's really a lot more to it.
And tell us about your study. So what did you find?
Right, so I guess it all began when we had Professor Ian Wicks from the Walter and Eliza Hall in Melbourne come and give a talk at Baker, and you know, at that point in time, he was really interested in G-CSF and GM-CSF as mediators of arthritis, but this field sort of developed that there's a lot of interest in, you know, the Th17 response, so IL-17, IL-23, and what have you. So we got interested in that point of view because when I was in Alan's lab, we sort of found that mouse models that were defective in cholesterol efflux genes such as ABCA1, G1 and ApoE had this increased stem cell mobilization, which was mediated through this IL-17, IL-23, G-CSF pathway, you know, that Klaus Slater originally described for neutrophil production. And so I sort of got thinking about how this could relate to rheumatoid arthritis, and really with the collaboration of Ian Wicks, we started to look at mouse models of rheumatoid arthritis. And we found that these mice had prominent monocytosis, neutrophilia, stem cell mobilization. And then when we started to look more deeper, the cells themselves had cholesterol defects. They were loaded with more cholesterol. So it suggested that there was something going on with the cell. And when we started to purify these cells, we noticed that they had decreased gene expression for ABCA1, G1,
really?
ApoE.
That's exciting.
So it was really exciting. And what it really did was sort of tied up those 5 or so years of work in Alan's lab in the genetic models, that now we'd seen a human disease where these genes were actually downregulated and precipitating in the phenotypes we'd seen in these knockout mice.
And so you have a mouse model of rheumatoid arthritis. Have you looked in patient samples yet? Have you been able to do that, or is it something you want to do?
Yeah, absolutely. So we're really fortunate to have a rheumatologist at the Royal Melbourne Hospital, Sharon Van Dornum, and she's had a long-standing interest in the association of cardiovascular disease and rheumatoid arthritis, but has never really had the gateway to study it. So I think it's really important to have good collaborators like that are passionate about the questions you're asking. And so with her and Gabrielle Goldberg at the Walter and Eliza Hall, we started to get patients, and recruitment's very early days, but what we have got is a little bit of an insight that the same mechanisms are holding up. So if we take white blood cells from people with arthritis, compare them to healthy age sex matched controls, we see a downregulation in ApoE. So it's really nice. And actually one of the fellow finalists, Prabhakar Nagareddy at University of Kentucky with his wife, Beatrice, who's also a rheumatologist, where we're looking to recruit patients through University of Kentucky as well, and really expand this patient population.
That's great. So, and it's nice that you're actually working with Dr. Nagareddy as well, who's also a finalist.
That's right, yeah.
So it's fun. So you can continue the collaboration. It's really nice.
Yep.
So yeah, what I like is the fact that you're able to kind of continue your work from your postdoctoral days, but able to really carry it on and
yeah, I think
in
it's
a
good
new
to have,
way.
Yeah,
right?
it's good to have some continuity to what you've been doing, and and then sort of extend it into a new field and hopefully have an impact on that field.
Right, right. So what do you think in terms of future therapy, or down the road, how do you see the findings of your work to be fruitful in that way?
So what we really need to do is, first of all, change clinical practice a bit and make sure people are really screened for cardiovascular disease in this setting. And, you know, there's now a push to make sure all these people are on statins. So even though their LDL cholesterol is not changing a lot, when they start to go on treatments with things like Actemra, which targets IL-6, and even some of the TNF-alpha blockers, while their joint disease might get a little bit better, they actually start to have increases in cardiovascular risk factors such as obesity, increased LDL and triglycerides. So while these treatments that are meant to help you are actually altering your cardiovascular risk profile. So, you know, whether we can restore these defects in cellular cholesterol homeostasis would be beneficial. So we've got that sort of arm to the project, and I'm not presenting this work at this meeting, but we've also been looking at a new type of therapy aimed at IL-6, which is blocking IL-6 trans-signaling. And so we recently had a study in cell metabolism with Mark Fabreo and Stefan Rose-John in Germany, showing that if we block IL-6 trans-signaling, we can limit inflammation and obesity. We don't change the metabolic profile. Right. So I think that's something we're looking at targeting in rheumatoid arthritis, and we're Stefan's currently working with Ferring, and this is in phase 2 clinical trials as we speak. So I think that's also an exciting new avenue, and we'll be really interested to see if that also aids in fixing the cellular defects in the cholesterol homeostasis in RA. So I think we've got a few nice avenues to explore.
Yeah, it's very exciting. So congratulations on being a finalist, and
thanks.
Good luck in the awards today, and we look forward to hearing your talk and all the details.
Yeah, thanks. Appreciate it.